Welcome to today's SilverlightShow webinar Introduction to XNA on Windows Phone 7. My name is Svetla and I'm pleased to introduce you to today's webinar presenter, Peter Kuhn. Peter is for the first time our webinar presenter, so the whole team at SilverlightShow would like to wish him a really successful session today. So you can ask questions during the whole session using the chat option in your webinar panel. At the end of the live webcast, we'll have a 10-minute Q&A panel during which Peter will try to reply to as many questions as possible within this time frame. If we have unreplied questions, Peter will reply to them via email within the next 3 or 4 business days. So I would like to give the word to Peter now to start with his presentation. Peter?
Thank you. Yes, thank you. Well, hi and welcome from me again. It's glad to see that some of you could make it, and it's great to see that there's interest in the community for XNA on Windows Phone 7. And I hope you enjoy the upcoming and the following 50 to 60 minutes and have fun with developing your own games afterwards. Let me briefly introduce myself. Some of you may know me under the name Mr. Goodcat, which is the name I use in the Silverlight community. I am a Microsoft certified professional developer, and I'm also a technology specialist for Silverlight development. And in 2011 I've also earned the Community Contributor Award for my participation in the Silverlight forums. Some of you may know me as a technical author here from SilverlightShow, where I write articles on Windows Phone 7. But in my normal daytime job I am a trainer and consultant for .NET, Silverlight and Windows Phone 7. You can find my website on www.pitorg.de, which is where I promote my trainings for Silverlight and Windows Phone 7 under the brand name Goodcat Trainings. And you can also find my blog there, and of course you can also find and follow me on Twitter if you like. I want to give you a quick overview of what we are going to learn today. First of all, I want to talk a bit in general about Windows Phone 7 and mobile games before we then start to take a look at the opportunities and options you have to develop games on this platform. And of course, then we will dive into more details about XNA. We will have a live coding session of approximately 25 minutes where we create a sample XNA project from scratch. And then we will talk about some of the problems that arise with XNA and the limitations XNA has, and how these limitations and can possibly be solved with the upcoming Mango update for the Windows Phone. And of course, in the end, we will have a quick outlook and the Q&A session. First of all, I think I don't need to talk much about the Windows Phone platform. I'm pretty sure all of you know at least some details about Microsoft's new mobile platform, have seen it or have seen some demos and videos, or maybe even own a phone. And all I want to say and all I want to emphasize again is that it really is a mobile platform. And the reason I emphasize this so much is because with XNA we have a development environment that allows you to develop software for what is called 3 screens. You can develop for the PC, for Xbox and for Windows Phone, all within the same environment. And sometimes you tend to forget that you actually develop for a very limited mobile platform. Just like any mobile platform, we have very limited CPU power. We have limited GPU power. We have to work with a lot slower file system I/O compared to normal hard disks or even SSD drives we have on the desktop. And of course we also have to work around network bandwidth limitations and unreliable networking conditions. I don't want you to be paranoid about this and start to prematurely optimize your games and applications for a mobile platform, which might not be necessary at all. But what I want is that you're always careful and considerate and keep in mind that all of these resources are really limited on the platform. And what I want you in particular is that you don't ever trust the emulator when you need to decide about the performance of your game or your application, because you will develop large parts of your game in the emulator, and the emulator performance will always be so much better than the performance on actual hardware. So don't ever draw any conclusion about the final performance of your game on the phone just from what you see in the emulator. Always test on a real device before you publish your game. Okay, so now when we take a look at mobile games in general, we can see the same picture throughout all the mobile platforms on the market, at least the big platforms. And what we see is that games always have the biggest market share in all marketplaces. Here we see the numbers for the Windows Phone marketplace. The share of games was even higher a few months back. I think it was up to 23 or 24% a few months ago. But 17% or 16% is what we see across all mobile platforms. And this always is the biggest market share of all categories. So apparently there's a really high demand for games from users. And I want to briefly talk about why this is also an interesting category for developers, because today people take their mobile phones with them wherever they are, and especially in all these short periods of idle time people have today when they travel or travel to work or from work, in the train, on the plane, or when they have to sit in a waiting room. They really enjoy just firing up a game for a few minutes and play that game to kill some time. And because of that, the nature of mobile games is a bit different from the nature of a full-blown desktop game. Games for a smartphone need to be simple. You need to be able to play them without a big introduction and description, and you also don't want to force the users to that they need to play long periods of time, for example, to finish a level or something like that. Games should be simple. You should be able to just play them for a few minutes, and this in turn is an interesting chance for small developer groups or even individual developers, because simple games are also simple to implement, and just with the right idea and with a clever game idea, you can really create something that that turns out to be very successful in the marketplace without a huge developer team behind you, and without huge resources you would need, for example, to create a full desktop game. Now, when we take a look at the options to create games for Windows Phone 7, then we have Silverlight and XNA as two equally treated frameworks living side by side and available side by side for the Windows Phone platform. These two technologies can also be partly mixed, a situation which even improves with the upcoming Mango update, something we will see in a few minutes. And the reason I mention this is explicitly mention Silverlight and XNA is because when I talk to people, a lot of people have the opinion that XNA is for games and Silverlight is for normal desktop application and for normal Windows Phone applications, which is actually not true. It's perfectly legitimate to use Silverlight to create your games, for example. The technology you choose does not determine what category your final product goes into in the marketplace. So Silverlight, for example, can be used and can be the better alternative to create a game if the included features of Silverlight make creating your game more effective. And if you need to make a lot of use of options that are in the box with Silverlight, then it's actually not a bad idea to think about using Silverlight for your game. And of course, the same is true for XNA. If you need to use some of the unique selling points of XNA, then you have to choose XNA, obviously. And sorry. And one of the main unique selling points, of course, is 3D rendering. And as soon as you want to create more complex games or want to make use of some more advanced rendering features, you also need to choose XNA over Silverlight. My personal opinion is that you should generally only do simple games in Silverlight with static content. I think that the threshold to choose XNA over Silverlight is pretty low, and as soon as you only have a handful of dynamic elements on the screen, or maybe want to show some frame-based animations, you usually will be better off with XNA. And this becomes even more true with the upcoming Mango update, because with some of the new features you can even mix those two technologies, and choosing XNA becomes even more reasonable after this update is applied. Okay, now let's take a first look at XNA. And first of all, let me just say that XNA still is a managed environment, so you have the same benefits from like in any other .NET or Silverlight-based programming environment, but it focuses a lot more on performance. And you all know that more comfort always means less performance. So one of the consequences of this approach is that XNA has none, or at least almost none of Silverlight's comfort features. In particular, we don't have a declarative UI. We don't have any SAML. We have no layout system that allows you to arrange your elements on the screen automatically or in a generic way. We have no animation system that is available to help you with creating or smooth animations in an easy manner. We have no data binding, and we also have no built-in controls and themes or styles. If you need controls, you need to build all the functionality from scratch. And we also have no sophisticated text rendering, because text rendering in XNA is based on bitmaps. So some of the very neat features Silverlight offers are not available and not really possible in XNA. So all this, if you look at this, might sound frustrating or a bit scary, but again, with the upcoming Mango update, some of these things will be made much more easy for developers, and we will also see that Silverlight has other advantages which make it more attractive to create games. When we take a deeper look at XNA, then we have to say that XNA really uses a different programming paradigm compared to Silverlight, in that it puts you in a more active role instead of a passive consumer. This is, I think, something that I should explain a bit more in detail, because when you are a Silverlight developer or a developer of any other Windows-based technology like WPF or Windows Forms or maybe even Visual Basic 6 or older technologies, then you are used to creating your UI, and after that the UI is displayed on the screen and you simply sit there and wait for some action to happen, some external event. For example, when the user clicks on a button, an event handler is invoked, and then you execute some of your logic in that event handler. With XNA this is very much different, because in XNA you work a lot less with events, for example. Instead, you often have some sort of polling mechanism where you instead, for example, regarding user input, actively ask the touch screen if the user has touched the screen, and if they haven't, then you do nothing, and if they have, then you process the information you get. And this is also, this different programming approach is also reflected in a central construct that is named the game loop. You can really imagine this construct as a loop, a very central and elementary loop that is performed all the time during the lifetime of your game. And all you do is you tell the runtime how often this game loop should be invoked in 1 second, and usually you would target like 30 times a second for the game loop. And everything you do throughout your game, no matter what, will originate in this invocation of the game loop. And actually this loop is split into two methods. One of them is the update part. This is where you put all your logic regarding handling input and executing custom logic, like for example computing computer AI moves and similar things, moving objects around on a screen. And the second part is the draw part, where you actually render all what you want to have on the screen to the screen using a graphics device. The game loop also forces you to, what I name it, think incrementally, which means if you want to move an object from one end of the screen to the other end in like 1 second, you can do that in one method invocation. Your update method that is responsible for moving objects around is invoked like 30 times a second. So if you want to move an object from one end of the screen to the other end, you need to move the object like 1/30th of the whole screen distance in each frame, in each loop. And this kind of thinking is sometimes difficult for beginners that have no game experience and may lead to mistakes first. But to see what this looks like, we will now switch to the live coding sample. And let me just fire up some software. Okay, so, and oops, sorry. And we will see what this looks like in Visual Studio. Okay, what we are going to do is we will create a XNA project from scratch, literally starting with File New Project, and we will choose Windows Phone Game. And I will just use a name, Flying Cat Sample, because that's what we are going to do. Let a cat fly across the screen of the phone emulator. Okay. The first thing I want to do before we start with some actual code is I want to take a look at the Solution Explorer to see what has actually been generated for us when we created this new project. So what we can see is that we have actually two projects in our solution, and one of them is the actual game project that has all the code in it, and the other one is a content project that is a special XNA project format to handle and maintain all the assets of your game. So the concept is that you import all the assets you want to use in your game, like textures or sound files or models, in this content project. And the content project, upon compilation, prepares these assets and processes them into a format that can then easily be used by the actual game project. And when you look at the project structure here, you can see that there is a content reference from the game project to the content project, which means by that link the game project has access to all the processed assets of the content project. What we are going to do now is we simply will add an existing item to this content project. And in our case, we will use this image of a cat, which is actually the logo of my trainings website, and add it to the content project. And when you take a look at the properties of this PNG file in the content project, you can see that there are two steps in the import process, in the processing of these assets. The first one is you can choose an importer that is capable of importing the file you have just added. You can see that there are different options here available, for example, for audio files or for model files. In our case, of course, we want to create texture. And then you have a processor. Again, many processors are available out of the box for sound effects, for textures, for sprite fonts, and for models. And in this case, again, we want to leave it at texture. So this two-stage process will convert our cat.png file into a texture object that can be used in our game for rendering. Another important detail here is that that each file in the content project has an asset name. By default, it simply takes the file name without the file extension, and this asset name is actually what you need when you want to access the fully processed asset in your game later. Okay, what gets automatically generated for you basically is one central class, and that is this game class, which is also derived from a game base class from the XNA framework. And some features, this game class comes with some useful features built in, and the generated code also has some additional prepared features for you. We will talk about each one of them in the next few minutes. Okay, let's just go through this step by step. First of all, we have the constructor of the game class. And what you can see here is that, first of all, a graphics device manager object is created. This graphics device manager is a wrapper around the graphics device, which represents the actual graphics, the actual GPU and screen rendering process on the phone. And this graphics manager, device manager object can be used to set all kinds of parameters for your game and for your application. And I actually will go ahead and set some additional parameters here just to demonstrate how this is done, and because it's good to do this. For example, one option you almost always want to set is you want to make your game full screen. And another thing that you should do is you should signal to the runtime which orientations of the phone you support, which means you can, for example, either support portrait or landscape mode, or both. And if you support landscape mode, you need to support both left and right. Okay, we will later see that the graphics device manager also gives you access to the actual graphics device to do the actual rendering. Other things that happen here is that the built-in content manager is set up. This is the link to the content project that we've seen just a few minutes ago. And this content manager gives you access and allows you to load the assets later on. Another important thing here is setting the target elapsed time property of the game class. This is what we've talked about, where you tell the runtime how often per second you want the game loop update and draw methods to be invoked. And by using this line here, you tell the runtime that you want to target 30 frames per second. Okay, that's a Mango specific feature. I won't talk about that. Then what we have here is an initialize method you can override to put your own initialization logic here. For example, when you need to create additional objects or prepare the game before it runs. But you should not do any graphic related actions here or load any content, because therefore we have this load content method, which is invoked whenever we need to load some content from the content project. Then we have an unload content method, which you don't need when you only use the built-in content manager to load your assets, but it can be used to clean up resources. And then we have the two methods we talked about, namely the update and the draw methods, where all the update and rendering processing happens. Okay, so before we actually start adding code to the game class, I want to create a small container class to give the code a bit more structure and to make it more clear what we are doing. And for that, I simply want to add a new class file to the game project, and I want to name it Sprite. This shall be a representation of an object on the screen that can be rendered and moved around. And to this end, I'm going to add some properties to this class, namely, first of all, a texture, because a texture is what we need when we want to draw anything visible on the screen, any image, any visible image to the screen. And then I'm also going to add a vector for the position of the element on the screen, and I'm going to add another vector for the direction the element is moving towards. Now you can see that I've not turned these vectors into properties, but made them public fields, which you might have learned is not such a good idea and not such a good style. But you have to know that the vector elements in XNA are actually structs, and if you decide to make them properties, you will run into all kinds of weird problems because of the nature of structs. So it's actually a better idea to make them public fields, unless you don't want to work with them from outside of this class. Then what we do is we add another property for speed of the object. The speed, I'm going to add a comment here. The speed is measured in units per second, most likely pixels per second. And the way this works is that we will take the position of the object and we will use the combination of direction and speed to update the position of the element on the screen. This approach is only one of the possible solutions. You can of course create this in a different way, but we will see that this will have advantages later. In addition to the properties, I'm also going to add a few methods, and you will see that these are very familiar. because they are just another variant of the update and draw methods that are implied by the game loop. But the draw method I want to make a bit different here. We'll talk about it in a second. Okay. So first of all, let's talk about the update method. I will now just implement the logic we have talked about, but I want to explain an important detail here, coming back to the think incrementally part I talked about before. What we receive in the update method, and we get that from the runtime when the game loop is invoked, is a game time object. And the game time object gives us information about how much time has elapsed since the last call of the game loop of the update method. So this is a way to find out how much of a fraction of the actual speed and direction we need to move the object to achieve the actual speed per second we are targeting. I hope it will become clearer in just a second. Let me just pull the elapsed seconds from the game time, which usually will be a fraction of a second, because this update method is invoked like 30 times a second. And we can then calculate a movement vector that determines how far we actually need to move the object. And this is calculated as the direction times the speed we are targeting. But since we not a full second has elapsed, we will multiply this speed by the fractional amount of elapsed seconds. We need to make that a float here. Okay, and now that we have the movement vector, we simply update the position of the object by the movement, and thus gradually incrementally moves the object around on the screen into the direction it is facing by the speed per second we are targeting. For the drawing of the object, we are going to use a sprite batch object. Sprite batches are a sprite batch is a helper class that is used to draw 2D content on the screen, flat objects that are not moved in 3D space, and it also has a helper method for drawing strings, for example. So if you, whenever you want to draw a 2D object, 2D content or strings on the screen in XNA, you use a sprite batch object. And to do that, we use the draw method of the sprite batch. And what we have to do is we have to pass in the texture and the position we want to draw the texture at. And the last parameter here is a color value, which can be used to give the texture a tint. You can colorize the texture by passing in a texture here, and if you use white, simply the colors of the original texture are used. Okay, one thing to note is that the position here always is the top left corner of the element, which means you can of course set up this differently and work with positions that describe the center of an object, but all these methods here expect the position as the top left corner, so it's easier to work with position that describes the top left corner in your software too, your implementation too. Okay, that's about the sprite class we can now use to describe objects that move around on the screen. And we will use this sprite class to move the cat sprite we have imported into our content project around on the screen now. And to this end, we are going to add a sprite field named cat to the game class. And now we will make use of the initialize method to actually create the new sprite. We will set an initial position, which I simply set to vector2, 0, which is the vector that points to the position 0, 0 on the screen, which is again the top left corner of the screen. We will set a direction we want the cat to move towards, which I just choose the vector that points towards the bottom right of the screen, the diagonal vector. And one important thing we need to do here with the direction vector is we don't want the direction vector to influence the speed the cat moves across the screen. We want the speed to be determined solely by the speed property we have added to the sprite. So what we do is we normalize this vector, and if you're not familiar with this, then just read about it or read the documentation about it. What this does is it makes sure the length of this direction vector is 1. So it will actually change those two coordinates, so the length is 1. And this makes sure that we always determine the speed of the sprite only by the speed setting and not by the direction vector we are setting. We also need to set the speed. Let's say we want to move the cat at 200 pixels per second across the screen. And the last thing we need to do is we need to set the texture we want to use to render the cat. But like I said, this is not something that is not done in the initialize method, but in the load content method. And in this method, we will now make use of the built-in content manager, that is our bridge, our access to the content of the content project, and we will use the load method to load a 2D texture for the cat sprite. And you take a look at the help here. You have to pass in an asset name to access the texture you want to load, and if you recall, this is by default the file name of the imported file without the file name extension. Okay, the next step to do is to actually update the position of the cat, and to this end we simply use the update method of the game class, and what we do is we simply call the update method of the sprite and pass in the game time that we receive from the XNA runtime. Internally, this updates the position of the cat. And finally, what we need to do is we need to actually draw the cat on the screen. So let's just call the draw method here and pass in the sprite batch that has already been created conveniently for us by the generated code here in the game class. One thing to note is that to use a sprite batch, you need to actually tell the sprite batch that you want to start a rendering, and you also need to end this rendering once you're done, or you will receive an exception when you try to do that. Okay, I hope I didn't forget anything, and we can try to run this sample and take a first look at it to see if it works. Let's just rotate the emulator into landscape mode, and you can see that the cat actually has been loaded. And what you also can see is that the cat started at the top left corner of the screen, and it moved right off the screen at the bottom edge of the emulator. And this is why I want to improve this sample a bit more and actually make sure that the cat does not move off the screen. And for this, we again use the update method. And after the cat has updated its own position, I want to check from the outside if the cat has crossed the screen boundaries and bring it back onto the screen if it has. For this, I need a few values. For example, first of all, I need the screen dimensions. For example, the screen width. And this is where the graphics device manager comes in handy again, because it gives us access to the graphics device, and the graphics device in turn gives us access to the viewport, which has information, for example, about the current screen dimensions. So we get the width and height from the graphics device. And we also need to get the width and height of the cat itself. And for this we use the dimensions of the used texture. And now we can check if the cat has moved off the screen boundaries. And we simply do that by checking if, for example, the x position of the x coordinate of the position of the cat is smaller than 0, then it has moved off the left edge of the screen. And in that case we simply reset the position to 0. And what we also want to do is we want to invert the direction, the horizontal direction the cat moves into, so it kind of bounces off the screen at the left side and then continues to move to the right. And we need to do the same for the right border, and the computation is a bit more complex there, because for this we need to take the cat's own dimensions into consideration. So the way this works is if the cat's position, which again is the top left corner, if the cat's position plus the cat's own width is larger than the screen width, then we know that the cat is moving out of the screen at the right side, and we then reset the horizontal position of the cat back to the screen width minus the cat width, right? And we want to do the same like we did before. We want to invert the direction, so the cat now bounces off the screen and moves back towards the left. And for simplicity I have created the same for the vertical movement here. It's just the same check to make sure the cat doesn't move off the screen at the top or bottom. Okay, when we run the sample now, hopefully we will see that the cat in fact does not, let me bring this emulator up, yeah, that the cat in fact does not move off the screen, and it's just working like that, just like expected. Yay. Great. Okay, so one other thing I want to show you is how you would integrate user input into this short sample. An important thing to know is that, once again, XNA is all about performance, and this means that by default none of the possible user inputs of the touchscreen is computed by default and processed by default. You need to explicitly tell the runtime what kind of user input you are interested in, and you can do that, for example, in the game's constructor by telling the touch panel, which is the class that represents the touchscreen, what gestures you are interested in. There's an enabled gestures property for that, and you can use that in our case, for example, to enable the gesture type of tap. So you can also use a combination of multiple gesture types, but for our sample we are only interested in the tap type. And once you have enabled these gestures, you can check whether new gestures are available in the update method of the game class, of the game loop. Check for user input. And the way to do this is, once again, you ask the touch panel class if gestures are available, and if gestures are available, you process them. Actually, I want to turn this into a while loop, because there's a possibility that multiple gestures are available at once, and you want to process all of them to not fall behind with processing of gestures, and to make sure that you don't process any old gestures, that gestures don't pile up over time. So first thing to do is to actually read the gesture from the touch panel, and once you have the gesture you can, for example, check the gesture type if you are interested in multiple gestures, and then you can react accordingly according to the gesture type you have. In our case we will always have tap gestures, and what we want to do now is we want to get the tap position from the gesture, and we want to use the position the user has touched the screen at to change the direction the cat moves towards. So we simply do this by doing some vector calculations, and we are going to use the tab position and subtract the current cat position, which results in a vector that points from the cat's current position to the new tab position. And we can use this to set the new direction for the cat. And once again, what we need to do is we need to normalize this new direction to make sure the direction itself does not influence the speed the cat goes at. Okay, so let's run this sample one last time. And what we should see now is that when I tap the screen, the cat actually changes its direction and moves towards where I touch the screen. Great. Okay, so that was this example, and now we are back to the presentation, hopefully. Yes, okay. Now that we've seen how a simple project looks like and how a simple sample works, I want to talk a bit about the problems that result from the lack of comfort we have talked about that XNA has compared to Silverlight, because this makes it really hard to create some things. For example, sophisticated user interfaces. Even if it's a game, you want to create menus and option screens, and this is really hard in XNA because you have to create all the control functionality that Silverlight has built in from scratch, and for example, use a third-party library for that. It's always difficult. It's also difficult to get good-looking text rendering because you cannot use scaling, or you have to determine what characters you want to use up front. You cannot make this dynamic. You even have to write your own logic for simple tasks like line wrapping, for example. And it's also difficult to create complex screen layouts. For example, when you need to show lists of data, or when you have data that doesn't fit onto a single screen and you need to implement scrolling, you again have to do all that manually. And another critical point, of course, is user input, user text input actually, because we have no text box. We have no possibility to use the software keyboard in our XNA games. There are workarounds to use some sort of input boxes for that, but if you want to integrate text input into your game natively, it's really, really complex. One possible solution to that is the upcoming Mango update. The developer tools are already available as beta version. Beta 2 was released just yesterday, and the final update will be released to the public in around September. And this update allows mixing Silverlight and XNA technologies in the same application. So you can use the best of two worlds and actually create the rich user interfaces you know from Silverlight in your XNA games too. Of course, this comes at a cost, and the drawback of this in particular is that you lose portability of your code. I've talked about the 3 screens possibilities in the beginning, that you have the option to create games for Windows Phone 7, Xbox and PC with XNA and actually move code and port code easily between those platforms. But as soon, of course, as you mix Silverlight and XNA in the same application, this becomes significantly harder to do. Nevertheless, let's take a look at a live Mango demo to see what this can look like. Again, just a simple demo. And I won't show any code this time because we don't have time for this now, and it's also complex or needs a few minutes to be explained how this works. If you are interested in this, I very much encourage you to read part 12 of my XNA series here on SilverlightShow. So this part explains and demonstrates how to do this in detail, comes with a full source of the sample I'm showing you right now. Okay. Okay, the emulator is off the screen. There we go. Okay, when we run this application, you can see that the first page is a normal Silverlight page. In fact, this whole project here is a normal Silverlight project, and therefore you can use all the normal Silverlight features you're used to. This page is created fully in SAML. You can make use of the layout, of the animation, of all the Silverlight features you're used to. We have a button here, and it acts and reacts normally to user input just like you're used to. The interesting detail is that if I click the play button here, the application moves to a second page, and on that second page rendering is handed off to XNA, and this second page is handled by the XNA framework. So what this demonstrates is how you can mix Silverlight and XNA pages within the same application. But there's even more. What's interesting about this particular page is that this red rectangle you see is updated and rendered in the same way like we have moved around the cat in the previous sample. So this uses the update and the draw methods of the game loop to do all the update and draw method and draw logic in XNA. But the text here, the Silverlight and XNA slogan, is a Silverlight text block element that is defined in SAML, and the animation you can see here is actually a rotate transform that is applied to this text block in SAML. So the interesting detail here is that we not only have Silverlight and oops, I didn't want to do that. That we not only have Silverlight and XNA pages mixed within the same application, we also have Silverlight and XNA content mixed on the same application page. And this opens a whole new set of ideas and a whole new field for game developers, because now you're able to create your gameplay logic and rendering in XNA, and the surrounding screens, like for example menus or high score screens and similar, can be done in normal Silverlight, and you can make use of all the normal Silverlight features, which makes it much more efficient and much more easy to implement nice and good looking games. Okay, back to the presentation. And that's almost all of it. I want to give you a quick outlook and just emphasize that, of course, what we've learned and seen today is not all that XNA offers. XNA has much more topics, much more advanced topics. Of course, 3D rendering is one of them, a huge topic. XNA has the possibility to handle sound and music, to handle multi-touch input on a much more sophisticated level than Silverlight does, for example. But the limited time does not allow to speak about all of these topics today. I also want to point out that the full trainings about XNA on Windows Phone 7 we offer here on SilverlightShow not only cover these technical details of XNA in great detail, but they also are about surrounding topics that are not so common in tutorials about XNA you can find on the web. For example, we also talk about monetizing options for your games with advertising or trial games. We also talk about how you can form a developer group, or how you can work as a single indie developer, what your chances and limitations are. And I always also share some of my experience from commercial game project, both from the desktop and Windows Phone I have participated in myself, which might also be interesting to you, for you to learn about. Okay, so I think that's it, and we can continue with the Q&A session now.
Peter, we already have a couple of questions. I'm just assigning them to you. So I think the first one was sent during your coding demonstration of the flying cat. Could you just read the question first, because people do not see?
Yes, of course, yes, okay. So the first question from Kamal is, should the screen width and screen height go in the update method, or can it be under the initialization code? The thing is that the initialization code is a point in time where the graphics device is not fully initialized yet, which is also the case why you don't load graphics-related content, for example, in the initialization phase. And you also always have to be aware of the fact that the user can turn, for example, the phone at any point in time. You can switch from portrait to landscape mode at any point in time, and this causes a re-initialization of the viewport, and the width and height properties will change. So it's you can handle this in different ways. You can react to these orientation changes, but it doesn't hurt if you use the update method to access these properties. I hope this answered the question. The second question I have here is from Georgi, and he asks, can Silverlight be switched off in Mango's XNA? Is it a project type while creating it? The approach that is used in Mango is that the actual project is a Silverlight project. So Silverlight has always the leading role here. And what you need to do is you need to tell the runtime that you want to hand off the rendering for a particular phone page to XNA. So the answer to that would be no. You cannot phase out or turn off a Silverlight completely, at least not at the moment. But what you can do, of course, is you can simply use only a single page and enable XNA rendering for this single page, so you don't have to show any Silverlight related content on the screen. Okay. The next question is by Julius, and is XNA tombstoning aware? I have written a separate part about tombstoning and XNA games in the SilverlightShow series about XNA programming. And the answer, of course, is yes. Silverlight is aware of tombstoning. Sorry, XNA is aware of tombstoning. The game class even has some built-in methods you can use and overrides to handle tombstoning. And you can also use the events of the phone application service class you are used to in Silverlight to handle deactivated and activated events, just like you would in Silverlight. And tombstoning in XNA implies, for example, that you have to reload your graphics-related content if your application was actually actually terminated during the tombstoning.
Okay, so at this stage I don't see any other questions. If any of the attendees has questions after the webinar, you may simply ask them inside SilverlightShow forums, and we'll have Peter reply to them inside the forums. So thanks a lot, Peter. I would like to invite all attendees to join the 3-day online training that you will deliver July 13th, 14th, and 15th. So this would be a 3-day live training, 4 hours a day, and all webinar attendees are entitled to a 20% discount for this training. We would also appreciate your feedback on this webinar. So please submit the survey we have displayed right after the webinar. 3 of you will win 3 ebooks by Peter Kuhn. These ebooks are made up of his 14-part article series on XNA. Okay, so thanks for being here. Thank you, Peter, for your first, I think, really successful webinar today. And we hope to see more webcasts done by you in the future.
Thank you too, and I'd also like to thank all for attending, and please provide feedback. I'm always glad to learn about how I can improve my trainings. Thank you.
All right. Have a good day, everyone. Bye.